I think I got cut off, so we're going to try this again. Hopefully my storage is holding on. Okay, so one thing should stick out in our IR spectra right now. So that would be right here. Okay, what is nice and kind of rounded right around 3,400? That is the alcohol functional group. So we know we're dealing with some sort of alcohol functional group. Okay, we don't have our molecular formula and we don't need it. So now it says, okay, determine our structure. We have our hydrogen NMR. So when we're looking down here, notice you have two singlets. Okay. And what does a singlet mean? It means the hydrogens giving these signals typically have zero equivalent neighbors, right? So there's also something important that we're going to think about in just a minute, okay? So zero equivalent neighbors. Okay, now checking our chemical shifts. This is the important one. We need to know what that 7 region is, 7 to 8 ppms. We've seen it before. This is our aromatic region. Our aromatic hydrogens are always in this shift, okay? So we already know we have an alcohol, so this must be our alcohol. Now some people go, well, aren't the alcohols down here in 3 to 4-ish, maybe 3 to 5-ish region on your chemical shift? Yeah, typically that's where they are when you're in, a very saturated, alkylish organic structure. But we have an aromatic ring, which is slightly electronegative, that big electron sink. So that's deshielding that hydrogen, shifting its signal down here. So this is near our OH. Okay, so again, our normal OH over here has been more deshielded due to the aromatic ring. Due to the aromatic ring. Okay, so we know we've got an alcohol. We know we have an aromatic ring. Our alcohol hydrogen shouldn't have any neighbors, and we've mentioned this before. I can't remember in lecture or lab videos, but that alcohol hydrogen behaves just like the aldehyde, and it doesn't feel any of its neighbors. So it's pretty easy to understand that singlet there. But what about this singlet here? And then there's a big star here that says carbon NMR. All we're going to learn about carbon NMR is that it tells you how many unique carbons you should have. So all we will learn about carbon 13 NMR is that every unique carbon has a signal. We're not going to memorize any chemical shifts for carbon NMR. Okay, if you take an advanced class, you would have a lot of analysis of that, just like we did for the chemical shifts for our protons. But we're not doing that for carbon, just an understanding that you have a signal for every unique carbon. Now, it says we can only have 2 unique carbons. So if somebody draws this structure and puts an OH on it, because we know we have an OH, this has more than 2 unique carbons, okay? It's got a carbon here that's attached to an alcohol. It has 2 carbons here that are a little bit further away from the alcohol. Then we have another 2 carbons here that are unique and a little bit further for the alcohol. And now I am missing my extra pens for a different color. And then we have, I'll just kind of dot it, we have this one right here. So we have A, B, C, and our D carbons there, okay? So we have 4 unique carbons here. And if you check your hydrogen splitting patterns as well, it's not going to match this right here. So we need to think about how we are going to get just 2 unique carbons. Okay, how would we do that? You can't branch off any more carbons because we don't have any more signals for it. Okay, So my question to you is, how do we make this more symmetrical? Symmetry is going to reduce the number of signals that we would have, okay? So how do you think we could do that? Well, who said we can only add one OH? Let's add another OH. And because I want to really reduce my number of signals, let's make this nice and symmetrical. Okay? So when we do that now, okay, and I'm going to draw in all my hydrogens so we can check our splitting pattern. Let's sort of analyze this structure. Now, in terms of the carbons, I've got these two carbons that are the same, and then all four of these carbons are the same. Okay? So I just have two unique carbons. So we just have two unique carbons in this structure. So that matches. So what about our splitting patterns? Well, this guy, this little hydrogen here, remember an alcohol sort of behaves as a barrier. It doesn't feel any hydrogen neighbors. Notice on this carbon there are no hydrogens anyway. So this hydrogen would have a singlet. Okay. And again, there are no hydrogens here anyway to worry about. But if there was, we need to make sure we realize that that little hydrogen sticking off here, and there are two lone pairs. Sorry about that. There's two lone pairs here. Losing battery power. We better hurry up. That kind of de-shield it from, shield it from feeling any neighbors around it. And again, these hydrogens are not neighbors. But check out that video where we did talk about that alcohol and drew a better little picture there. Now, what about these ones here? So some people go, well, this hydrogen has one neighbor. So wouldn't it have a 1 + 1 = 2, a doublet? Well, no. These are identical hydrogens, okay? So hydrogens that are the same, they do not split each other's signal. So this would also be a singlet. So it's really important. I'm going to put a star next to this one and put it down here. Chemically equivalent hydrogens don't split each other's signal. So chemically equivalent hydrogens don't split and affect each other's signal. This came up earlier in our packet where we've looked at some examples. This hydrogen is the same as this hydrogen. Okay, they're like identical twins, so they're not going to affect each other in any way. Okay, so that's all we're going to mention about carbon NMR, and it's helpful because it'll tell you how many unique carbons you can have. So you could try different aromatic rings, putting the OHs, your two OHs in different spots, and counting how many unique carbons you would have. This is the only one that's going to give you two unique carbons. So finish up your NMR packet, keep sending those questions in, taking your time, being all cozy, getting all your schoolwork done, and staying healthy. And I will talk to you soon. We're going to be starting some brand new chapters next week. Next week is our last week before spring break. We're going to be shifting to some amino acid protein chapters, which are required for biochemistry, which most of you would be going to next upon transfer. So I've found some awesome Khan Academy videos that are going to help us with that section, and kind of have a nice little mellow break from some of this craziness. So I will talk to you soon. Don't forget about your quiz coming up for NMR, and any exams are going to be announced pretty soon, trying to maintain our schedule as closely as we can. But again, there might be some changes to that as well. Talk to you soon. Bye.